Good morning, everyone. I'm standing for Maria Yan, who unfortunately cannot be here today because of illness, and I would like to pass her apologies to all of you. And it is my great pleasure to be here today to speak to this gathering of interested mind and excited about design. So in our lab, we studied the process of product design. There is often a romantic notion that when a designer starts from a great idea and works really hard and then have a great product. But the reality is actually more like this, that in the early stage of design, the process is like this. And we believe that how you design in this early stage is actually very important and can influence the outcome. And there are research that's showing that 70% of the cost of the product development are determined at the 30% of this early stage. So once you make a critical decision, it's hard to change it afterwards. So to put it in other words, if a company or organization have a bad idea initially, it's hard to work it out and come up with a good product. And there are different ways to innovate. One is technology-driven, and MIT is famous for developing all types of technology, and a small portion of them later on becomes a new family of products. For example, this Roomba, it's a robot cleaning sweeping machine. So it actually, after the technology is ready, it took the team more than 10 years to develop into a real product that can be launched to the market. Another way to innovate is focus on the market. So let's look at different populations of groups. For example, looks at baby boomers, look at millionaires to understand what they want, and then develop products specific for them. So this like iPad is probably address the need of people that who want to be connected all the time, want to surf the internet, etc. And in our lab, our research focused more on this user-centered product design. So we take the approach, observe designers who trying to understand individual users' needs and wants and design products that address those needs. So this example here is a gorilla port. It's come from a Stanford design courses where the student designers observe that when people are traveling, going around, sometimes they want to take photos and they want the cameras to stay steady. However, nobody wants to carry a heavy tripod with them when traveling, right? So they come up with this idea with lightweight and low cost joint type of tripod that you can wrap around in a rail and make it steady and to keep your camera steady when taking photos. Another example of user-centered design products comes from MIT, who the designer used to be a student, a CS student, and traveled a lot, and coding his homework and trying to upload and sync his coding into a thumb drive, and that is not very convenient. So he coded a solution for himself, and later that becomes a successful company, which is the Dropbox. So everyone can sync their documents online, offline, wherever they are. So I would like to start this session with a short design activity. So please take out the paper and pencil that are on your seat. Okay. And let's take 2 minutes and design a vase. If you finished, you can hand it up and show that around. Great, thank you. So I see a lot of variations, like containers in different shapes, cylindrical, other shape. Next, let's do another round of design. And this time, please design for a better way for people to enjoy flowers at their home. If you finished, would you mind hand it off so I can see the design? Thank you. So yeah, I see. Well, things. It's hard to see from the distance, but I guess I see things that other than the containers. So you probably feel the difference that both of them are for like flowers and for people to enjoy the flowers. But because this design task is framed differently, so you may come up with various different answers. And this is actually an IBM design challenge. One of the takeaway from it is that how a problem is initially formulated can heavily influence the outcome, especially when people are more solution-orientated instead of thinking of defining the problem. In our research, we're also trying to focus on this and to understand how to better define the research design problems so that the products comes out are more valuable. And the research approach that we take in this research, first, our group have this goal of gaining a fundamental understanding of the early stage of design, that is how the designers design. So a challenge that the industry faces is that a company may say that we have a good approach, a good methodology, but they usually do not have the interest, have the time or resources to evaluate that one method is actually better than the other in a controlled manner. So in our lab, we conducted controlled experiments with designers and other stakeholders to validate our hypothesis about early stage design and to understand which works better and trying to pass that knowledge to designers and help them to design better. And we took this approach to a broad application from consumer products to sustainable systems and large complex engineering systems, etc. And next, I'm going to give a few examples of that. So first, visual representations of design. In this study, we looked at two different types of tools or visual representations of early stage design. One is sketching and prototyping. And we want to learn like how they would influence the design process, thinking process of a designer. So we conducted experiments with student designers and give them a prompt to design a package to hold a sandwich and a cup of coffee at the same time. And we conducted 1 hour experiment with each individual designers and give them 30 minutes to first generate at least 3 ideas and then 30 minutes to refine their ideas. And in the first 30 minutes, there are 3 experimental groups. So one group of people can only use prototyping, one group of people can only use sketching, and another group can freely use prototype or sketching. So here are the number of ideas generated by designers in the 3 groups. Not surprising, you can see that sketching generates way more ideas than the prototyping only group, and the free prototyping and sketching is kind of in the middle. So like sketching, maybe it's easier to generate ideas, and I'm going to show some examples, and you can see the ideas come up from the 3 different groups. So in the sketching groups, there are a lot of various ideas, like put the containers on the hat. But later on, in the second phase, they need to refine the idea and actually create a container that they can hold, that durable, that they can hold both the drink and sandwich and walk around. So they kind of select or narrow down to one idea and build this physical prototype. To evaluate these ideas, we resketch them into this consistent form. So we want to take away variants of the different skills that designers have on building the prototype. So we have an industrial designer resketch all these designs. And we posted them online on Amazon Mechanical Turk and did a crowdsourcing design evaluation. We asked people to compare a random pair of designs on how creative they think the design is, how durable, how comfortable of holding, and how easy to load sandwich and coffee, etc. of these designs. And then here are the results of some of the evaluations. We see that the prototyping here, the prototyping group, the designs generated in this group are perceived to be much more aesthetics pleasing and also much more functional, have a better functional performance than the designs generated in the other 2 groups, in the sketching groups. And we think by observing the process of the designer's design, we think the reason is when in the first phase, the designers focus on building the prototypes. They kind of take into consideration of all the physical constraints. And even though they do not produce as many ideas as the sketching group people, they have more time to think of details of how to make a joint, how to actually connect different pieces. So when they're iterate in the second phase, they were able to produce products that are more usable and looks more aesthetically pleasing. And what makes us things the most interesting is the creativity. So in this time, the free prototyping and sketching group actually produced the most creative result. So if you remember the original ideas produced by the designers, the sketching groups looks like they have a lot of crazy ideas, a hat, a container, or even a drone, like carry the sandwich and coffee. However, these ideas are not that feasible to build in the second stage. So even though they have creative ideas in the first phase, these ideas got screened out. But only prototype at the first stage kind of limits people's ability to think wildly. So a combination of sketching and prototyping in the early phase actually contributes to the creativity for the second stage. To summarize this study, we found that being able to both sketching and prototyping in the early stage of design can contribute to the creative ideas later on. And prototyping in the early stage helps the designers to come up with designs that are more aesthetically pleasing and also have better functional performance. And in our group, we also conducted studies about sustainable design, and we care about the environmental impact of the products, and we're trying to to understand the design process to eliminate this impact. And here is a product life cycle, which convey the idea that a product can cast impact on the environment in all stages of this life. And previous research kind of focused on the production and end of life of the product development and trying to come up with methods to reduce the energy or resources waste when producing the product or the waste and pollution produced at the end of life. But we are focused more on this use phase of how the users are using this product and how that could change the product's environmental impact, and also how users or how people would perceive sustainable product, so that when company generate sustainable products, people would be willing to buy it, so it will be a success in the market. And we look at one renewable energy system, the residential solar PV systems. So there are solar panels that homeowners can put down on roofs and generate electricity for them. And also it has zero waste production, so it has the potential to eliminate the CO2 increase. In this study, So solar panels has been exist for a couple of decades, and the technology is becoming more and more mature. And our question is, how can we better design this product so that people would be more willing to adopt it and want to own this system? So the two research questions we have, one is, what are the most important attributes of a residential solar PV system? And how would homeowners make trade-offs between these attributes that they care about in the decision process of adopting solar? And we start this project with interviewing with stakeholders, including homeowners who had or had not adopted solar, installers who work in the industry and help people to put solars on their roofs, and energy consultants and other professionals in this industry. And from the interview, we kind of get an understanding of this process of a homeowner adopting solar. So we find that the solar installers actually comes into play in the early stage, that the homeowners, very few of them directly go to like Home Depot, buy a solar panel, put them on their roof. Instead, they would first talk to solar installers and try to compare different installers and make a decision of who they want to work with. And then the installers would recommend a couple of selections of solar systems. Again, homeowners make a choice of which system that best meets their needs, and the installers will help them to install and maintain the system afterwards. So based on what we find from these interviews, we further designed a survey using a method called choice experiment. So here is an example question in the survey that it has 3 combinations of installers with different features. So here, we asked the survey participants to choose a combination of the installers that they think they would like to work with the most. Here you can see the installer one has the shortest project time. So if a homeowner work with them, they would get their solar installed in a really short time. And the second installer could provide them the largest savings, so they probably have a lower price for selling solar. So if the homeowners choose this installer, they could potentially save more money. And the third installer, they provide a best warranty. So if homeowner go with this solar installers, they know that the rest of the 25 years of the lifespan of their products, it's almost maintenance free. So by observing how the survey participants make their choices, we can infer which of these different attributes about solar installers are the most important to them. Similarly, we have a set of questions that focus on the solar system, and we evaluated the solar panel efficiency, the panel visibility, so whether this solar panel would be very visible on the roofs or not. If it's less visible, it means it's more aesthetically pleasing. And we evaluate the inverter type failures, how often the solar panels may fail, and also the solar panels' environmental impact. And here is the mathematical model we use to interpret the results, and here are the results we got from the survey. So we distribute the survey among around 1,700 homeowners in both California and Massachusetts, and they covered both homeowners who had adopted solar and not. And so we get understanding of people's preferences for these attributes on a large spectrum. And here, in this chart, the higher a dot is, means people would have a stronger preference for this corresponding attribute level. For example, here, people prefers this 70% saving on electricity bills more than the 10% saving on electricity bills, which is not surprising. People want to save more by installing solar. And here, the range of this what we call utilities shows how important each attribute are. So here you can see the savings. Their utilities cover a large range. So when people making choices, they really care about how much they can save. So this kind of reflects the state that homeowners still have the mindset that solar panel is an investment to save on electricity. As the cost of solar goes down, we may see a difference that people might have a stronger preference for the different attributes, the product features of solar system. So here you can see here for how the installers would collaborate with this, with homeowners. We see a slight preference for more collaborative design, collaborative type of installers. So homeowners, they probably prefer the installers to work with them more closely and to kind of custom-made a solar system for them instead of a standard services. But these attributes is less important when homeowners make their choices. Other important attributes including the warranties installers provided and whether the installers have a good reputation or not. So this has it plays an important role in homeowners' choices. And for the systems, we found that besides saving, the failures in 5 years is the second most important attributes. So again, homeowners cared a lot about the reliability of the system. So first, they do not want their system to break often, and second, if it breaks, they want the the installers to take care of it, so they don't need to worry about maintenance. To summarize this study, we found that homeowners cares not only about the solar systems, but also about the services that installer provided when they're thinking of adopting residential solar. And we identified a couple of important attributes, for example, savings on electricity bill, installers' reputation, length of warranty, etc. So those informations could potentially help stakeholders like solar installers and manufacturers to set goals for their designs and services so that they can satisfy the needs of a broader homeowner population. Another set of sustainable design that we looked at are design for sustainable user behavior. So in this project, we think of how the users use a product and how that would influence the environmental impact. And there are the strategies of reduce a product's environmental impact in the use phase falls on the spectrum from more product in control to more users in control. A couple of examples. To save water usage, here is a water faucet that you have to press down to get water, and it will shut up automatically, so make sure that the water will not be wasted. But you probably have used it in the public bathroom or on the airplane. It's kind of annoying to keep pressing it down to get water. A different idea to save water is this Pluckley Sink. So here the designers did not put plug in the sink, so the users will have to tilt the sink to empty it. So this is kind of inconvenient, so that people may say, oh, I don't want to use too much water, and because I don't want to flip the sink too often. And the strategy we investigated is called eco-feedback. So here the idea is the water faucet which tracks the usage of water and then present that information to the users and make them be aware of how much they have used and also remind them that to conserve. And this design is not as invasive as the previous two, so the users have full control of whether they want to conserve water or not. Because it's kind of advantage and both disadvantage. Disadvantages if the eco-feedback information fail to engage the user, they could just entirely ignore this information and do not conserve. So in our research, we want to study how can the designers design eco-feedback products to better engage the users? So we think it's not only important to present quantitatively clear resource usage information, but also to engage the users emotionally. And we want to understand how, what kind of emotions users would have when using this type of products, and what are the emotions' roles in influencing product use behavior. So we going through the literatures and existing product ideas and selected these 8 products that are commonly used in daily life so that people can use to conserve resources. And for each of the products, we created different type of designs. And first, we conducted a survey with university students. We did this in 5 universities in both US and Saudi Arabia. And here are the results, a students' evaluation of all the 32 designs. And we see that some of the designs are more emotionally evocative than the others. And this emotion is actually correlated with users' perception of the effectiveness and appealing of the design. So it's both important for products to be quantitatively clear, to present the clear information, and also engage with the user emotionally. And after that, we improve the design and create these gift animations to convey how the product works, create a quantitative design and a figurative design that's supposed to be more emotionally evocative, and a few other examples. Here's a polar bear designs that if you don't, you can save the polar bear by flipping the switch. So we have this group of neutral design. This time, we test these designs in the in-lab environment, and we show the participants these designs and provide them with a product usage scenario and ask them to imagine what they would do and would feel in different cases of using the products. So there is a conserving scenario and a wasteful scenario. And we collect people's emotions by a self-reported methods, and we selected 15 verbal descriptors of how people would feel when using the products. And also we evaluate how people might do, like whether they would be willing to turn off the faucet or not, and how do they think of the design. And here is a distribution of all the emotions in the conserving scenario and in the wasteful scenario. So in the conserving scenario, people would in general feel happy, satisfied with conserving, and when they waste resources, they will feel guilty and upset. And then we further conducted correlation analysis to find the link between people's emotion, their perceptions of the design, and their willingness to conserve. And what we find is interesting that is the negative emotions are connected strongly with people's intensity to conserve. However, positive emotions are more correlated with their perception of the design. So a takeaway from this is a designer may want to use the design to make people feel guilty so that the design would more effectively encourage them to conserve. However, for the design to be successful and well accepted by the users, they may want to support positive emotions. So that would make the users appreciate the design better. Okay, I think I'm short on time, so I'm going to quickly go through the other projects that are happening in our lab. So we have a research product that looks at the product system design, desalination plant, renewable energy, and we have studies that focus on the tools that can facilitate designers to generate ideas or to refine their designs, including additive manufacturing and computation facilitate design. And we studied designers, their creativity, and we studied users in extreme cases, including a developing country. And the last section is Maria's vision about building the future of designers. So as an educator and a faculty in the engineering school, one of the goals is to educate the next generation of engineers. So here are a portfolio of classes that Maria teach, and also as a student in her lab, we are highly involved in these classes, including an introduction to design class, where students have the experience of building a mechanical design to achieve a challenge, and also a user-centered design to understand the process of talk to users and understand their needs. And a toy product design, where the freshman designers would spend a semester and come up with a toy that you can play. And also, this is a class that Maria co-teaches, which has students coming from both engineering, management, and also receive industrial design. And these three, it's a very interdisciplinary team, and students work together and come up with these products. And some of them, like the first of this one, they had actually launched to the market, and there was a startup company come from this. And also these classes are often sponsored by industrial partners. And this is the Design Exchange, which is an online repository that's built between Berkeley and MIT, so it has hundreds of design methods and case studies. The designers, both engineering students and designers in the industry, can use this Design Exchange to search for methods that can help them. And this is a startup company that Maria has, and they focus on building this STEM-orientated toy that kids can put them together and later on get a party lamp. This is the final result, and there are a lot of kids come and test it with the products, and so provide especially girls are super interested in products. They get some hands-on activity to put on the lamp, and later on they have a product that they can keep to themselves. So this project has been successfully funded by Kickstarter, and now you can get it on Amazon. Here are everyone in my lab, and as the end, we do have a belief in the design process, and we think that can guarantee the success. Thank you very much. Okay.
Any questions for Dr. Brown? I have one question about the sensitivity of the question, how you phrase the question, how it shapes the design process. Did you look into that any further as to perhaps how sensitive the questions were, or are there different ways or a best way to ask the question?
Yeah, that is really a good question. So from a research perspective, we do find that how we ask the research question could change the research outcome. So what we think is important is trying to explore fast in the early stage, and to feel fast and then learn fast. So not to fixate ourselves on one thing, but explore a broader opportunities, broader space, to keep open-minded in the early stage, and also so that later on we can narrow it down to a question, to a design framing of the question that's the best. And another way to address this is actually talk to people, talk to the users, talk to stakeholders, because if it's a user-oriented design, you have to understand what the users needs. And we cannot assume, the designers cannot assume we're professionals, we are experts in all the domain. So we need to talk to people who have the real knowledge about domain, like renewable energy or desalination plant, and get perspective from them. And that could help designers to better frame their problem. Yes, please.
You mentioned about the emotional response, with the positive or negative, but was there any clear sense of whether that had an impact on their actions or their behavior?
So the question is whether the emotions would have impact on people's actions. So in this experiment, because it's in lab, so we're kind of using a question to ask people how they might behave. We ask how likely you're going to turn off lights, turn off faucet. Definitely, we give them a 1 to 7 scale from definitely not to definitely. And we did find that negative emotions, so if people feel extremely guilty about wasting, they are much more likely to choose, I will definitely conserve. Yes, so the emotions are connected with people's behavior. And we want to further evaluate that with prototyping and the physical prototypes too, and see how people actually do.
Thank you very much.
Thank you.